say 18.7. Someone might share it.
21.24.
21.24 units?
Meters per second.
Yep. Questions to hear? The silence that comes from just being enthralled. It's just, you're just so overwhelmed with the awesomeness of physics. All right, so I'm gonna put a stake through the heart of chapter 3 here. I did not assign the master set for chapter 2, so we need to do that plus, well, let's see what we got here. So 28, and February 4th, that's today. Then we've got the 11th, 18th, 25, and this will be 6, 13, 20, 27. All right, so homework quiz for 3, do a week from today. Let's make master set of 2, do the 13th. We'll be allowed also do that day.
And they're 11.
Pardon?
She's helping me see.
So the 11th, a week from today, homework quiz for chapter 3. 13th, master set for chapter 2. The 18th, master set for 3. And that'll be good for now. See if I can write that slightly bigger. Pardon?
What was the 13th?
The third thing, all right, so on the 11th, we have the homework quiz for chapter 3. On the 13th, we have master set 2 due. On the 18th, master set of 3.
No, we turn them in on paper or?
I prefer them handed on paper. But if, for some reason, you feel the need to submit it online, in the syllabus, there's a naming convention for the file. IMG 5736.jpg is not a legitimate format, and it's not a legitimate name for the file. The naming convention. It also should be submitted in Blackboard and not to my email. If I were submitting it, fonts, George, underscore, master set 02, or write out master set or something like that, dot PDF. That's if it's in one document. If you're not quite sure, if you have JPEGs and you need to get it into a single, let's say you got 5 JPEGs, you need to submit it in a single PDF. If you go into Microsoft Word, which all of you have access to, import the pictures into Microsoft. So you bring up the Word document, there's a insert file, find your JPEGs, put them in. Make sure that they're not on top of each other, because sometimes software will do that, where you got 5 images all on top of each other. Make sure they're in the correct order, and then when you go to save it, you can save it as a PDF.
That's underscore MS02.
That's underscore MS02. That would be for master set 2. Or for a lab, it'd be the name of the lab. The syllabus gives more detailed information.
That's just so submitted online.
If you do, I still prefer it on paper, but if you do submit it online, 1, submit it in Blackboard, 2, I I think I've gotten one document submitted electronically that actually has a correct name. Because when I download it, I have to then do extra work to try to figure out whose document it is, if I don't have to go, or I have to add your name to it. Either way, this represents you. If you don't want your name on it, on the file, then to me that says you don't want credit for it.
Is the master set something we can find on Blackboard?
Yeah. If you go to module 1, chapter 2, if you scroll down, there should be something that says master set.
Oh, okay, I see it.
Any other questions at the moment? Yes, Julissa.
When we're done with it, since you want it paper, do we just like put it up there when we come in?
Yeah.
Yeah, just
Yeah.
a stack right there, okay.
Yep. Similar to labs, there should be, somebody starts out a stack in a spot.
Oh.
I should not have to ask for them. Like, so if you've done it, you will hand it in. If you're done early, you can hand it in early.
The homework questions works for us, right?
Say it again?
The homework question 2, whatever.
So the homework quiz 3 that's coming up. That if you go to the textbook homework problems in Blackboard, I'm gonna pick one of each type and present that as the quiz. So this is the quiz. This is
Homework
not
is for us.
the actual using the problems and studying them. You have the opportunity to actually know all the answers before you walk in to the quiz. You're not submitting that homework. Instead of having you submit that homework, I've supplied the solutions, and I'm just gonna pick some problems from it and ask that. And I need to remember, I should set my alarm. I have stuff to hand back. All right, let's take 5. A question on the floor. If I've got some vectors that I'm adding together, so I've got an object here and I have a force. Let's assume, that's just absolutely horrible. Let's try that again. I'm gonna draw that better, if possible. I have an object here, and I am applying force to it. I'm gonna assume that I'm drawing the forces properly. So that I got a force going that way, a force going this way, a force going that way, and a force going that way. And I want to figure out the total force. If I've drawn my arrows properly, not just the direction, but the length also. So this is, when we did the force diagrams, we did not necessarily draw the arrows the correct length. We just were indicating what force in which direction, but not the size. But if these arrows do represent the forces in the magnitude as well as direction. So that's the longest one, that's the largest force. If I want to know the total force without knowing any numbers, I can find the total force by adding those forces together. When I add forces together, since I can't do it mathematically because I didn't give you enough information, I do it graphically. I take one of them, it doesn't matter which one. I can start here and then go counterclockwise. I'm going to start at some point, and I'm going to draw an arrow that's in the exact same direction and the exact same length as best I can. So if done properly, those two would be the same length, same direction. I'm now here. I take the next one. So same length, same direction. And then the next one. And then the next one. All right, so all I've done is I've added them here. I haven't come up with an answer yet. The equivalent in scalars is, if you treat this as the addition, then if I said what's 1 plus 2, and what you wrote down is 1 plus 2. Yes, that is 1 plus 2, but you haven't really answered what the intention is. So all you've done is just added them. You haven't come up with an answer yet. With any vector addition done graphically, the final answer is a vector from where you start to where you end. So the resultant is a vector that starts here and goes in that direction. That's my resultant right there. If I wanted to figure out the magnitude of that, well, I'd have to tell you the magnitude of one of these. I could say that this is, let's say that this is 10 Newton force. Then R there, well, if that's 10 Newtons there, that would put it to here. So it's a little bit more than 10, and I would just roughly say it's about 11 and a half. The magnitude of my resultant, about 11 and a half Newtons. Obviously, this was done with fingers and moving and trying not to twist my hand as I moved. What I'm looking for, if I give you something like this, is close enough. Just get close enough. I should be able to look at this and go, yeah, those are about the same direction, same length. Yeah, yep, and yeah, those are all good. You actually have an answer. Now the master set question that's similar to this, I don't ask for the magnitude of the final answer, I just ask you for the sum. And there was another thing that was, any questions on this? There was something else that I was going to connect with this. And I am.
The box must be included with an angle with the tension force.
Ah, okay. Thank you. Now, if instead I give you a different drawing, this time, instead of having the lengths be accurately represented, I'm going to give you lengths that are not accurately represented. I'll give you the right direction, just not the proper lengths. So I have an object here. That arrow is pointing this way, this way, and that way. Now, if the lengths are not proportional to the actual magnitude of the force, and I told you no other piece of information, it'd be impossible to add these. However, if I do give you one piece of information, at least you have some fighting chance here. If I said that this was in equilibrium, and so what are the 3 different criteria that all mean the same thing, all mean that something's in equilibrium? There are 3 key things that could be stated to tell you something's in equilibrium. I guess 4 if you count my stating it's in equilibrium.
The velocity is not changing.
Okay, the change in velocity is 0 or velocity is constant.
The deceleration is also 0. And the total force is 0.
Technically. So if one of them is true, the others are true. So if I said that the acceleration was 0 for this, or said it was in equilibrium, or the velocity was constant, or the total force was 0, then if I add these together, they should add up to 0. Well, if they add up to 0, I'm going to end up back where I started. This case, I did not end up back where I started, so this would not be equilibrium. Over here, I don't know magnitudes, but I do know I have a force going this way, a force going that way, a force coming back. If I drew anything other than an arrow the same length as this one, I could not get back to 0, and then back to 0. So that would be the addition of the forces, total force equals 0. If I gave you these 3 forces, and there is a 4th force, I'm going to make the claim that I've drawn these to the proper length. So the length does represent the object. And go on with saying that I have a 4th force that's going to put this in equilibrium. Well, I'm going to add up the 3 that I know. So I just start somewhere. I'm going to take that first one there. That's the first one. Then I'm going to take that one. Then I'm going to take that one. And that seems off. Yeah. And the 4th force, if this is an equilibrium, that 4th force must connect up back where we started. Because if the total is 0, I can't have any gap between my beginning and end. So the 4th force must be that to get me back to 0. So now there's a lab that I did not have you do, where you actually you'll use the force tables, you come up with the forces, you actually add them graphically. Do note, if I just said add up these 3, this was a question in the lab. If I add up these 3, what is the relationship between the sum of these 3 and that 4th force required to put it in equilibrium? Well, in black here, I have the 4th force that's required to put it in equilibrium. If I just said, what's the sum of those 3 right there? The sum of those 3 is a vector from where you start to where you end. What's the relationship between the 4th force put in equilibrium and the sum of the first 3? As you look at this, what is the relationship between the blue and black lines, or vectors?
It's the same.
Pardon?
It's the same.
Not what is the same. Pardon? Yeah, okay, so the magnitude is the same. What about the direction piece?
They're opposite.
Yeah, 180 degrees apart. Or anti-parallel, or however you want to say it. We did something similar with scalars. Actually, no, we did something with adding force, just vertical forces in the second lab. If I have 4 plus -1 plus -2, the sum of those is 1. But if I ask what is if those are each representing a force, the sum is 1. But if I ask what is the force required in order to have this equal to 0, in other words, equilibrium, well, the force required to add to this to put it in equilibrium would be -1. That this was table 3 and then to table 4 in the second lab. So, anyway, questions up to here? All right, chapter 4. We will now talk about the link between chapters 2 and 3. Chapter 2, we dealt with forces. Chapter 3, we dealt with motion. What is the connection between the forces and the motion? And what I consider the most important equation, I've written it up here before, but the most important equation in physics, F equals ma. This F right here stands for the total force. And I have a video where I talk about the different ways you can represent total force. It's just supposed to be understood that that F right there stands for the total force acting on an object. Mass of the object, and despite what some students have told me in the past, mass of the object will have, in SI units, has units of kilograms. And then acceleration we've just talked about, so change in velocity here with a change in time. And if you're given the weight, there's also weight divided by acceleration due to gravity. But oftentimes, more often than not, you're told the mass. So let's start out with a simple case. Something perhaps a little bit brighter. That is not different. I have a 3 kilogram box. I am pushing on it with a 6 Newton force. So it's the universe that has only this force and that box. This is an example of other, because I haven't really deliberately talked about what's causing it or what actually causes the 6 Newton force doesn't matter. I talked about forces coming in pairs. There's some mysterious thing that's pushing on the box. There's a 6 Newton force acting back on it. But the problem itself is just this piece right here. So the question is, what is the acceleration of the box? Like a jug, what's the total force?
3 kg. Kilograms, 3 kilograms.
That is 3 kg. What is the total force?
6 newtons. 6 newtons.
Yeah. So I have 6 newtons.